My last recording got cut off there. So we finished up this one right here by doing our log splitter, our change of base formula. Now this one, it's kind of the same idea, except we're going to use this idea right here, the quotient rule. So we have the product rule, the power rule, and the quotient rule. All of these come from our exponent rules that we learned in another lesson. So we just kind of treat them backwards. So like when we add the exponents, we were multiplying, same idea. So I call this one the backpack rule because basically you think of this guy's holding something in his hands and then he sees somebody, so I'll put it back here in his backpack. So this P can go back and forth. That's because a power to a power you multiply. So we're multiplying the power times the power because the logarithm is the power. So this one right here, it just wants us to use that rule to express this as the sum or differences of logarithms. So I just break this down to be the log base t. And then since 8 is on the top, p is the positive one. And then that would be minus log base t of w. So we read it just like this right here, where the top goes in the front with the positive, the bottom went in the back with the negative. Now it's not so much the front and back, it's about the positive negative. Because remember when they were on the denominator, they had a negative exponent. So that's why they get this negative right here. So if I wanted to go the other way and express this as a single log, the first thing I always do is I bring all the backpacks in, all these exponents. So that I would first rewrite it as log of x to the power of 1/5. So I'm just using the power rule here, going from this form over to this form. So I'm bringing that p back up. This one I'm going to keep it as a minus, write it as log, sorry, writing and talking. Log of y to the power of 5. Now you might think, why did we not bring up that negative? And really we could have. If I had written it as log of y to the power of -5, the next step would come out the same. So watch what happens in this next step. This would be z to the power of 3, where I bring it together as the sum and differences into one single log. I always like to draw the line right here so I can tell the top from the bottom. Everything that's positive, like this guy, will go on the top, x to the power of 1/5. Everything that's negative would go on the bottom. So here's why I could have written it as the power of -5. That would have been the flipper, which would then bring him back down here to the denominator. It all goes together. When I'm rewriting it, I make sure that the log stays the same base. These were all log base 10. When I broke this one up, I had to be careful to make sure they stayed log base t. So I can go back and forth as needed. Now I'm sure you're thinking, why would I ever need to go back and forth? And it would be for a problem like this where we're trying to solve. So if I had it broken into 2 logs, I can't condense this. I can't solve and solve for x until all my x's are together in one place. So I need to bring these 2 logs together using that product rule. So I express it as one single log. And then that means I would need to multiply the 2 inside things, the x and the x plus 3. So now these are all together in one single log. It still equals 1. And now that I have it condensed to be one single log, I can rewrite it in exponential form. So remember that this is log, which means it's log base 10. So I'm going to express it in exponential form with that base of 10 to the power of 1 equals that inside stuff, x plus 3. Now notice in all of these problems, we should end up with a regular non-log equation by the second step. So when I switched it to the exponential form, it wasn't log of 10 to the 1, it was just 10 to the 1. So now I can solve it just like always. This is going to end up being a quadratic. 10 to the first is, of course, 10. I would distribute that x. And then to solve a quadratic, we always have to get it equal to 0. That would give us the x squared plus 3x minus 10. If you have that quad program on your calculator, you're welcome to use that. If you were doing it by hand, you would factor it out into the x plus 5 and the x minus 2. Then remember, we set each factor equal to 0. So that would give us the answers of -5 and +2. Now remember that we cannot take the log of a negative. when we looked at the graph, we saw that it just didn't exist back here. So if you tried to type log of -5 into your calculator, it would just give you an error. So the final answer is only 2. Because if you tried to plug in this -5, even though algebraically it worked with the quadratic, it wouldn't work into the logarithmic equation. Now this one here is slightly different. I do have 2 logs, but I cannot combine them because they're on either side of the equal sign. So I don't have to condense 2 logs. Instead, I have the situation where log equals log. Well, in this case, you can basically just cancel. And there's kind of a complicated reason of why they cancel. We're basically taking 12 raised to this power on both sides. But bottom line is the logs cancel each other out. So we're really just left with 3a minus 3 equals the 9 minus 3a. So again, notice by 1 step or 2, you should have the logs out of your way. Now if I solve this for a, I need to get my a's together. Careful not to cancel those. Add that 3 over. And then divide by 6. It's always a good idea to double check because we saw that this can happen. So a equals 2 would be 3 times 2 is 6. 6 minus 3 is positive. I can take the log of a positive. 3 times 2 is 6. 9 minus 6 is positive. But see how it might have come out messy. If this had been, say, 5, 3 times 5 is 15, that would have made me take log of a negative. So just be careful. We can only take the log of a positive. Okay, and then last, if we go the other way and we have an exponential equation, there's one of 2 things we could do. If there's a way I could rewrite this answer in the form of this base, so for example, 64 is 4 cubed, then I can say kind of the same idea as this orange one, that if 4 to this power equals 4 to that power, then this power must equal that power. The minus 2x must equal the 3, which means x must be a -3 halves. Which is all great and fine and dandy if you can rewrite it as that power, but that's pretty rarely going to be the case. So instead what we can do is just like this green one where I switched it from logarithmic to exponential, I can switch it from exponential to logarithmic. So I could rewrite this in its log form, where I had log base 4 of 64 equals the -2x. And then this is something I can use for the calculator, just like we did on this example right here before we got cut off. I can use my change of base formula. Okay, so just type that straight into the calculator and it's actually going to give you that same 3, which is why I end up with that exact same answer of -3 halves. So this one turned out pretty. That won't always be the case. This one right here, just like we saw, there's no magical base of 2 raised to a pretty power to give us a 9. I'd have to use my logs. Log base 2 of 9 equals x to see what crazy decimal makes that happen. So get that calculator handy. We're going to have to use that change of base formula. If you have the button, remember if you hit math and scroll up, it's the one called log base, LOGBASE, and it should make it look real nice and pretty. If you don't have that button, it's really easy. You just type log of 9, make sure to close that parenthesis, divided by log of 2. Okay, make sure to close that parenthesis. Okay, it should give you the decimal of 3.1699 blah, blah, blah. Keep that in your calculator. Do not round until the final answer. Okay, dot, dot, dot. Well, in this case, I have it equal to x, so I'm done. So that is my answer. So let's round it to 4 decimal places, 3.1699. But this next one, there's going to be an additional step. See, the power is not just x. So I start out the same. I say log base 10 of 9 equals the power 2x plus 1. Okay, luckily this is the button straight from the calculator. Log base 10 is just log. So I hit log of 9, I get the decimal of 0.9542, blah, 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 blah. And here's where I was saying, don't round it. Keep that whole thing in your calculator, and then let's go through the steps of solving with that decimal in the calculator. So of course, first I'd have to subtract 1. So with that crazy decimal still in my calculator, I would hit -1, making sure to use the minus over here on the side, not the little negative on the bottom. -1. Okay, see how it says A and S because it's taking it straight from that previous answer. So that's going to give you this decimal, -0.04, blah, blah, blah. That, of course, equals 2x, which means the last step I would need to divide both by 2. So again, with that still in my calculator, I hit divided by 2, okay, which should, again, say A and S because it's taking that previous answer. And then it's going to give me the final crazy decimal answer. So that's going to be a negative 0.022. Hit a button. 0.222, now it would round up to 9. Okay, now it seems like kind of a crazy answer. You could actually check your work by plugging this in for the x right here. So you'd say that number times 2 plus 1, and then take 10 to that power, and it's going to get you a decimal really, really close to 9. Now I know that one was a little sneaky. Let's try one more. Now this one right here, I have something going on. Notice how this was 10 to the power. This one has this 7 that's being multiplied. He's not attached to this power of 5x. So the first thing I need to do is get him out of the way. Okay, don't worry about this as a decimal, just keep it right there as that fraction. So I have 10 to the power of 5x equals the fraction 12 over 7. And then I'm going to change it to the log base 10, well that's nice again, of the 12/7. I'm just going to type that in carefully in the calculator, equals 5x. The log base 10, that's the nice one. I can just hit LOG, and then I'm going to type in that fraction, 12 divided by 7. So I just used my button, LOG right here, since it was log base 10, and just type the fraction straight in like that, 12 over 7. Close that parenthesis. If it had not been a pretty log base 10, I would just have to be careful, just like we did here and here, to divide it by the log of the base. That gives me the decimal of 0.234, blah, blah, blah. Since that equals not x but 5x, I have one last step to solve for x by dividing by 5. So again, keep that straight in your calculator, divided by 5. That gives me the final decimal answer of 0.0468. If you have any trouble with any of those, please let me know.